Okay, so we just talked about all of the angles that have a common reference angle. And what you're going to notice on the next slide is they all have a similar pattern with their sine and cosine values. They're basically going to be the same numbers, but different positive and negative signs. So let's take a look at our next slide, the next, I guess, page on your PDF. And, ooh, can I stretch this out? Oh, whatever. Here we've got, you know what, hang on, let me fill in the angles and radian measures on this. You can do the same. I'm just going to pause right here and fill in all of my angles and radian measures in these boxes right here, but in all 4 quadrants. Okay, so I've just filled in all the degrees and radian measures here. You could have gotten that from the previous screen. What are these points, these things here? These are to calculate our x and y coordinates for every single one of these angles. Remember what we said a few minutes ago, that the x and y coordinates are the same as the sine and cosine values of these angles. So, you could get it from your calculator, but it's going to give you a long and oogly number for most of these. What I'm going to use is our knowledge of special right triangles. And I'm only going to work in quadrant 1. I'm going to pull out this first triangle right here. 30 degrees. Alright, that is a reference angle of 30 degrees, so this is clearly a 30, 60, 90 triangle. We know that this is the unit circle, so our hypotenuse is 1. The ratios on the 30, 60, 90 triangle are x, 2x, x squared root of 3. So what we know is that our long side is 1. 1 equals 2x, therefore x equals 1/2. Therefore this side length here is 1/2, that's our short side length. And our medium side length, therefore, is x squared root of 3, 1/2 times the square root of 3. And if we say that that's the square root of 3 over 1, then that's going to be the square root of 3 over 2. We'll multiply it by 1/2. So this side length is the square root of 3 over 2. Now, remember what we said. If I draw this reference triangle in here, make my little right angle here, what we just said is that this side length is 1/2, this side length is square root of 3 over 2, and this radius of the circle slash hypotenuse of the triangle is 1. Remember, this vertical distance is our sine value, in other words, our y coordinate. Our y coordinate is 1/2. The horizontal distance here is our cosine value, or our x coordinate. So our x coordinate is square root of 3 over 2. And ta-da, we've got our x and y coordinates for, our x and y coordinates, and therefore our sine and cosine values for a 30-degree angle, theta. Now let's take a look at this 45-degree angle. Guess what? That's another special right triangle. That is going to be the 45, 45, 90 right triangle. So let's draw that out here. Where's my pen? There we go. This is our 45, 45, sorry, I didn't mean to do that in green. 45, 45, 90 triangle. We have x, x, x square root of 2. Look, this is our angle, 45, therefore we know the other angle is 45. Now we know our radius is 1. And since 1 is x squared root of 2 in the 45, 45, 90, 90 triangle, we need to divide both sides by the square root of 2. And remember, in the United States, we don't leave a number with a square root in the denominator, so we want to rationalize this denominator. Multiply both the numerator and the denominator by the denominator. Square root of 2 over 2, and we're going to get, in simplified form, the square root of 2 over 2. So guess what? Both of these side lengths here are the square root of 2 over 2. And following on that same pattern, as we just did with the previous triangle, we know that that is both the vertical height, which is our sine value, square root of 2 over 2, and the horizontal distance, which is our cosine value, square root of 2 over 2. Woo-hoo. Let's take a look at our third triangle here. I'm going to erase this stuff, make some space. The third triangle is made with our angle of 60 degrees. And guess what? That's another 30, 60, 90 triangle. It's just rotated a bit. I made this messy. Okay, so we've got now the 30, 60, 90 triangle. That doesn't really look good, but this side is 60. Sorry, this angle is 60. This one's 30. Again, we know our hypotenuse is 1. Now, that means our short side is going to be down here. This is 1/2. Our medium side is over here, square root of 3 over 2. So remember, this is that same 30, 60, 90 triangle is just rotated. So here, in this case, our x-coordinate, our cosine value is 1/2. That's the horizontal distance. And our y-coordinate, the vertical distance, and our sine value is the square root of 3 over 2. Now, all of these are positive. Why? Because we're in quadrant 1. Let's take a look at the values for every single other of these points and angles on the unit circle. And we're going to fill them in as we go. Now, remember the unit circle has a radius of 1. So what is this point up here where our 90-degree angle is? Well, that's not 1, 0, which is our starting point at 0 and 360 degrees. It is 1, 0. I'm sorry, 0, 1. 0, 1. Okay, so looking at this 120-degree angle, in other words, 2 pi over 3 radians, take a look at that. That's the same 30, 60, 90 triangle. So we're going to have the same coordinates. We just want to take a look at which quadrant this is in. This is in quadrant 2. Our x-coordinates are negative and our y-coordinates are positive. So it's going to have the same coordinates as this guy, but negative x, so negative 1/2, positive y, square root of 3 over 2. Aha! Which means that it's going to be the same pattern for 135 degrees or 3 pi over 4 radians. Same reference angle of 45 degrees, therefore the same horizontal and vertical distances as the 45-degree angle, but since we're in quadrant 2, negative x-coordinate, positive y-coordinate. Again, same pattern for 150 degrees as the 30 degrees angle. We have a reference angle of 30 degrees, so the same horizontal and vertical distance, but x-coordinate is negative, y-coordinate is positive. And so now, I want you to pause this video and use this pattern that we just identified and what you know about the positive and negative x and y values in quadrants 3 and 4 to fill in the rest of your coordinate points. I'm going to pause. I want you to pause the video and do this too. Then press play again to see if all your coordinate points are correct. Alright, so check your work here. Notice where we should be having the same positive and negative signs on different x or y coordinates in the same quadrant. Alright, so just to recap, first quadrant, both x and y coordinates are positive, both cosine and sine are positive. Quadrant 2, x coordinates are negative, y coordinates are positive. So cosine values are negative, sine values are positive. Quadrant 3, both sine and cosine, both x and y coordinates are negative. Quadrant 4, our x coordinates are positive and our y coordinates are negative. That means the cosine values are positive and the sine values are negative. So here's what this circle means. Let me take 5 pi over 6 radians, for example. I don't even have to use my calculator. The cosine of 5 pi over 6 radians is negative the square root of 3 over 2. The sine of 5 pi over 6 radians is 1/2. Right? Let me take this 240-degree angle right down here. What I know then is that my cosine of 240 degrees is negative 1/2, and my sine of 240 degrees is negative square root of 3 over 2. If you were to type cosine of 240 into your calculator, making sure it's in degree mode, it's going to spit back out negative 0.5. Guaranteed. We could do the same with any of these. What do we have? 12 plus 4, 16 angles that we've just put on this unit circle. So we've got the unit circle. We've just learned about the unit circle, and what I want you to do is make sure that you practice these problems for homework. What do we have here? I'm going to leave these problems for the warm-up for tomorrow. How about that? And here's your summary. You can read that on your own. Please remember that you do have 2 homework assignments, all right? One is going to be homework 7.3 on My Open Math, which is this that we learned on the unit circle. The other is homework 7.2/8.3, which is what we did yesterday and finished today regarding right triangles. Please also read the text section 8.1 in advance of tomorrow's class so that we can move more efficiently. Thank you for being patient tonight. I hope you have a good night, and I'll see you tomorrow. Bye-bye.